Okay, so you've seen some examples of coordinate proofs, or at least setting up the coordinates in such a way on your shape that it's easier. One of the coordinates that's always the easiest to work with is 0, 0. So you always want to get one of your vertices of your shape on 0, 0. Sometimes it's the center, but usually it's one of the outside vertices. The other thing is, if you have right angles somewhere in that shape, it's very useful to use that right angle to have one of the sides of the shape along the x-axis and one of the sides of the shape along the y-axis. Now, you don't always have shapes with right angles, but when you do, you can use both axes to make life easier. Otherwise, you'll just have to pick a side and put one. Like an example, if I have only one side of that triangle could go along, you could make it the x-axis or the y-axis, but then it makes your calculations a little bit easier. So when we look at example 6, part 1 says a right triangle. Well, a right triangle has a right angle, so I can take advantage of the two legs are on the right angle. They form the right angle. I'm going to put one leg along the x-axis and one leg along the right axis. So here's me doing that right now. Let me do that in green here. So one leg is supposed to be 5 units. I'm going to pick 5 units. There we go. There's 5 units there along the x-axis, and I'm going to do 3 units along the 5 units along the x-axis, 3 units along the y-axis. And so one of my vertices is going to be 0, 0. Because this was 3 units, that means I went up 3, and this coordinate here, that coordinate there, is going to be 3 units up and no units to the left or right. So no units left or right, 3 units up. And this one here was 5 units long, so it's 5 units to the right. So that's going to make this one here 5, 0, and no units up. Okay, and if I want to finish my right triangle, there it is there, and I've got my right triangle. Now some of you are asking, well, could I have done it differently? Yeah, you could have done it differently. You could have instead chosen, let me simplify this. What if you wanted to go 5 units up and 3 units to the right? You could have done that. Okay, so we'll do that again. I'll do it in red here so you can see it's a different. It's just if you wanted to, you could go 5 units up. There's my right angle, and 3 units this way, and you will get 3, 0, and here you get 0, 5. Either one would work, red or green. Okay, so the second part says an isosceles right triangle. What is an isosceles? 2 sides the same. Right triangle with the length of the leg being 10 units. Well, that means I have 2 legs of 10 units, and it's a right triangle, so the same thing happens. What I want to do, there's really only one way to set this one up because they're both the same, is to go 10 up. There's 5 up, 10 up. And there's 10 to the right. Now, if you wanted to, you could go 10 down and 10 to the left, and you would still be okay. You just have negative coordinates. This is going to be 10, 0, and this is going to be 0, 10, and you connect it. Ooh, bad connection. Okay, and this is the same as this, and there's your right angle, and you've got that. You got it labeled there. And then you've got the other vertex is 0, 0, which makes life easier for counting 10 units to the right and 10 units up.